So in the last video, I was showing you a problem where you had to convert atoms of iron to grams of iron. And we set it up using two conversion factors. We first use Avogadro's number to convert atoms to moles. All right, so we used Avogadro's number. We set it up so that the atoms would cancel. 1 mole of iron is 6.02 times 10 to the 23rd atoms. And then we used molar mass to go from moles to grams. And we got the molar mass of iron from the periodic table. We plug the numbers into our calculator, this divided by this times this, putting parentheses around anything that has exponents in the denominator. And this was my calculator answer, 1,792.142857 grams. Now, you know, probably, hopefully, definitely, that you can't leave that many sig figs because we are limited by the measured quantity. Our measured quantity was 3 sig figs, 1.93 is 3 sig figs. So I need to round this to 3 sig figs. The best way to do that is to first switch it to scientific notation. So I'm going to move the decimal 1, 2, 3 spots, 1.792142.857 times 10 to the, I moved it 3 spots, so 10 to the third. Okay, still too many sig figs. Now that I have everything to the right of the decimal, I can get rid of anything to the right of the decimal, and I need to leave 3 digits. So there's our 3 sig figs. This 2 here is less than 5, so I don't round up, I stay. So my final answer is going to be 1.79 times 10 to the third grams of iron. So what this is telling us is that if we have 1.93 times 10 to the 25 atoms of iron, they're going to weigh 1.79 times 10 to the third grams, or 1,790 grams. Okay, good. So now that we know how to do this two-step process, we know how to use molar mass and Avogadro's number. And we can go from grams all the way to particles, or particles all the way to grams. Let's add in one more. This is something I call the composition ratio. So let's say you have a molecule of glucose. So glucose is C6H12O6. And in 1 mole of glucose, you have 6 moles of carbon. Or in 1 molecule of glucose, you have 6 atoms of carbon. So that 1 to 6 ratio, or 6 to 1 ratio, that's called the composition ratio. That's what I like to call it, composition ratio. So basically we can say for every 1 mole of C6H12O6, you have 6 moles of carbon. Or you could say for every 1 molecule of C6H12O6, you have 6 atoms of carbon. If I can write 6 atoms of carbon. So you can write 6 moles of carbon for every 1 mole, or 6 atoms of carbon for every 1 molecule. So the point is, it's a ratio of the composition of the specific substance you're talking about. So think about this. For every 1 molecule of glucose, how many atoms of hydrogen do you have? 12 atoms of hydrogen. For every 1 molecule of glucose, you have 6 atoms of oxygen. So you just look at the actual compound and you make a ratio of the specific elements in the compound to the whole compound. Let's say you had a water. You know that for every 1 molecule of water, you have 2 atoms of hydrogen. For every 1 molecule of water, you have 1 atom of oxygen. Well, you could use molar quantities instead. You could say for every 1 mole of water, you have 2 moles of hydrogen. For every 1 mole of water, you have 1 mole of oxygen. All right, so how does this tie in with all the calculations? Let's try something out here. Say, how many atoms of carbon are in 10 grams of glucose, C6H12O6. Okay, so this is our strategy. You have glucose. You can't start talking about atoms of carbon if all that's been given to you is grams of glucose. So you're going to have to convert your grams of glucose, grams of C6H12O6 to moles. You always have to convert to moles. Okay, you're going to go from grams of glucose to moles of glucose. Once you've converted to moles of glucose, you can then convert to molecules of glucose. Once you've got molecules of glucose, you can then go to atoms of carbon. See what I'm doing here? To go from grams of glucose to moles of glucose, you just need molar mass. So that will just do this conversion here. And then to go from moles of glucose to molecules of glucose, you're going to need Avogadro's number. So molar mass to do this, Avogadro's number to do this, and then to go from molecules of glucose to atoms of glucose, that's where you use that composition ratio, that for every 1 molecule of glucose, you have 6 atoms of carbon. Okay, so let's see if we can set this up. 10 grams of glucose, C6H12O6. You need the molar mass of glucose first. So you need to go to the periodic table. You have 6 carbons. Each one of them is 12.0 grams. You have 12 hydrogens. Each one of them is 1.01 grams. You have 6 oxygens. Each one of them is 16.0 grams. Do the math, add them up. I know it's around 180 grams, so I'm just going to use that. Okay, so I'm going to say 1 mole of glucose, C6H12O6, is 180 grams of C6H12O6. Okay, cancel out grams. Now we want to go from moles to molecules. That's when we use Avogadro's number. So we're going to go 1 mole of C6H12O6 is 6.02 times 10 to the 23rd molecules. And I'm getting myself very squished here. So I went from grams to moles using molar mass, and then I'm going to go from moles to molecules using Avogadro's number. So this here is molar mass. This here is Avogadro's number. Everybody see that? Okay, now I still need one more step. I want to go from molecules to atoms. And you can see I have no room on my board. So I'm just going to continue it down over here. So bear with me. We're going to say 1 molecule of C6H12O6 has 6 carbon atoms. This is my composition ratio. This down here, composition ratio. So I used molar mass as my first conversion, Avogadro's number as my second conversion, composition ratio as my third conversion. Okay, now I'm ready to pick up my calculator and see what my answer is going to be. Okay. All right, 10 divided by 180 times 6.02 times 10 caret 23. Remember, if you're using the EE button, don't do the times 10, okay? And then times 6, so this is a numerator over here. Okay, I end up with 2.006666 times 10 to the 23rd. If I'm going to round it to 3 sig figs, I end up with 2.01 times 10 to the 23rd carbon atoms. Okay, good. All right, so that is it for our conversions. We learned how to use 3 conversion factors: molar mass, Avogadro's number, and composition ratio. The 2 most important ones are molar mass and Avogadro's number. You're going to use them a lot, especially molar mass. Molar mass we're going to use quite a bit in the next few videos when we start doing stoichiometry. Before we get into stoichiometry, we're going to learn how to balance chemical equations. So we'll spend some time doing that, and then we'll get into stoichiometry. All right, but the conversion factors you've learned so far are molar mass, Avogadro's number, composition ratio. You should feel pretty comfortable with those. Okay.